Well, hey y'all, how you doing? We say y'all down in the South where I'm from. I speak fluent redneck, so hopefully you can understand the brand of English that I use. My name is David Neal. I go by Reverend Geek on the Twitters. I try to be funny. Sometimes I succeed every now and again. And I am so excited to be here at the first NDC in Minnesota to talk about Electron and to cover kind of the roadmap of what we're going to do is we're going to talk about Electron. Why do we want to use Electron? What problems does it solve? Why do we even care about building desktop apps in this mobile first, web first world that we live in? And give you a crash course on how to get started and some tips from my experience so far. And this is one of my favorite photos. Took this in Chattanooga, Tennessee. They win the interstates. So I want to tell you about my story or my journey into picking up Electron and using it. I've been a .NET developer for a long time. I was at the PDC in 2000 when C# and ASP.NET were announced. They gave every one of us in that conference a little book called Presenting C#. And being the nerd that I am, I went back to the hotel that night and read it cover to cover. It wasn't very big, but it like introduced me to the C# language. I fell in love with it, and I used it for many, many years. And when the time came that I needed to create not only some command line tools and some desktop applications to help solve a problem at my company, I needed to be able to allow, give some of my customers who use Macs the ability to also run this software. And I thought, well, there's Xamarin, which our mobile team uses and is having great success building cross-platform mobile apps. I've heard that there's a Xamarin, app for desktop applications. I think I'll just use my mad.net skills and create some desktop apps. And I found that, yes, through portable class libraries at the time and, Mono, that you could create a shared .NET code base that you could leverage on any platform. But that's kind of where the benefits ended. So Xamarin Mac does not get the same amount of love as the iOS and Android, tools. And native UI is still extremely hard. It's up to you to build the WinForms or WPF or whatever you're going to build on Windows. Have to use Xcode UI Builder to build the UI for Mac, and on Linux, God help you. Me being a web developer, I didn't know how to do any of those things, and my extent of experience building desktop applications prior to this was like, here's a big gray window with a big giant button, click me, and that's it. I don't have really good desktop UI skills. And deployment was really hard because if you're going to build, it's kind of easy for Windows because there's .NET exists on most modern desktops and you can deploy that. But getting Mono on other systems, Mac and Linux, it's not that easy. And at the time, this was before Microsoft acquired Xamarin, and licensing was a deal breaker. This is not something I was going to build to sell to our customers. These were just utilities that our customers could use to solve a problem. And, I couldn't justify spending $1,000 a year on a license, for just some things that were going to make some folks' lives a little bit easier. And so I came away feeling really frustrated with, the prospect of having to learn how to do UI on all these things and just not getting that much benefit. So I heard of this thing called Electron, and the pros being that it's HTML, CSS, and JavaScript. These are things I'm comfortable with. I've been a web developer since the late 90s, and I can build decent looking UIs. I know how to use these technologies. There's lots of tools that are available, and this sounds like it's pretty cool. Electron uses Node and Chrome, which is already cross-platform, and it's some technologies that I was interested in along with JavaScript, and it was really awesome. So it's not just, and when you're creating an Electron application, it's not just any version of Node, or you're not having to depend on the a specific version of Node or Chrome on a person's computer. It's bundled into the application, so it's completely standalone, which brings up deployment is really, really awesome, because when you package up an Electron application, you're packaging this version of Node, this version of Chrome. You're not having to deal with cross-browser, compatibilities, because you're only targeting Chrome. You don't have to deal with older versions of Node or anything like that. You're targeting, a specific environment, making the development a whole lot simpler. And my experience building Electron was a lot more success. As I started getting into it, it was, there were a lot of problems that were already solved. There were a lot of tools that were available in the Electron framework that just made the whole experience a whole lot easier. And as I mentioned before, since you're targeting a very specific version of Node and Chrome and the V8 engine, the V8 JavaScript engine, you can use the latest and greatest language, syntax, and features of ES6 and beyond, and not have to do any transpilation or anything like that. Really, really cool. So I'd be remiss not to mention that there are some drawbacks to building an Electron application, and that would be its HTML, CSS, and JavaScript. If you're not already a web developer, that might be a bit of a challenge. And, we all love to bash on JavaScript. A little bit of history of Electron. It was created by GitHub for Atom, the Atom editor, and it was formerly called the Atom shell, but to reduce misunderstanding of what it's capable of doing, they rebranded it as Electron, and it's been active and around since January of 2013. 1.0 came out in 2016, and they just released 2.0 a few days ago. And it's got a lot of nice new features. You can have in-app purchasing on Mac apps and some other cool things. So some of the features that Electron brings to you that makes building desktop apps so much easier is there's of course, you got rapid development. There's things like themes. If you've used an Electron application in the past, you may have, a lot of them have the ability to change the look and feel of the application. Well, it's just CSS, right? CSS and some images. You can easily add those same kind of features into your desktop applications, where you can give someone the ability to create a light or dark theme or something like that. There's all kinds of native user experience things that are built in. There's, of course, the ability to have shared code. Possibly, if you have an existing web application that you want to, take and port to a desktop application, there's a good chance that you can reuse a lot of the UI and even some of the back end code if you're using Node. And Electron and the folks at GitHub and people who have contributed to Electron have solved a number of complex problems that make building and distributing Electron applications a whole lot easier. So things like, if you've used on a desktop application, a little notification pops up at the top and says a new version's available. Do you want to, restart and run it now? That's kind of baked into Electron. You can provide that same kind of experience to any of your the folks that are using your applications. And the native user experience extensions, things like file open and save and print and desktop notifications, tray notifications, those are all, a common API inside Electron that you can invoke and whichever operating system the application's running on, you're going to see the native browsers or the native windows pop up for file open and save or printers or whatever. So it creates a kind of a seamless experience that people would expect. So why would we want to consider building desktop applications? There's a lot of use cases, a lot of scenarios, offline being one of them, being able to create an application that someone can use disconnected from the internet. And if you want to have access to local hardware like printers and devices and be able to control those kind of things like medical devices, medical or things out in the field. If you need an application that's running on premises, this was my use case. I used to work for a SaaS company where we had a product that was all web-based, but we had this need to be able to integrate with other people's systems to get their data out of their system or synchronize our data with theirs. And we couldn't ask these companies to open up their firewall and let us reach in and get their data to synchronize. We needed an application that was running on premises that could communicate with our APIs and so forth, and to generate, do things like generate reports, generate integrations, and so forth. If you're building internal line of business applications, it might be a little bit easier editing local files, having that local storage. If you have an idea that you want to create an application for the App Store, you can monetize your application that way in the Apple or Windows app stores. Kiosk applications, like out in the retail or in hospitals or manufacturing or whatever, where somebody goes up and interacts with a machine to get something done, is a great option. And sometimes desktop is much easier from logistics and red tape and so forth of being able to just maybe you're building an application and there's 4 people that need to be able to use this application inside your company, and getting this application deployed and updated on an intranet is really hard problem to solve with your IT. Now, this strikes fear into the heart of a lot of IT folks, but maybe you can build an application that just solves that one problem. You can hand them a flash drive or give them some files that allows them to run your application and not have to go through all the loopholes and the red tape of getting it deployed to an intranet server. And sometimes desktop applications still just feel like the best kind of tool for the job. This is a big list of ideas that I brainstormed and came up with one day, just looking at different desktop applications. I'm not going to go through and read these all to you, but just to give you an idea of some of the problems you might solve or opportunities you might have to build your own desktop applications. Now, you probably have seen Adam. Adam used to be the golden child of editors. People, that were using Sublime. Adam came on the scene and took things by storm. Most of you have probably used Slack at one time or another, or you love to hate Slack, or have some kind of love-hate relationship with it. But Slack is what caught my attention. When I found out that Slack, the desktop client, is an Electron application, that just kind of blew my mind. It was like, this is a problems with performance and memory usage and all those things aside, this is a really nice looking, well designed, easy to use application that is essentially a web app running on your desktop. Oh, that's cool. And then the new kid on the block, if you use Visual Studio Code, it is an Electron application. And when Visual Studio Code came out, my first thought was, I just assumed Microsoft was using .NET to build their editor. And I thought, well, how did they solve the problems that I ran into, trying to build cross-platform desktop apps? And, I started poking around and trying to get more information about it. And I just was shocked. I was floored that Microsoft is using these open source technologies, and it's not .NET, it's JavaScript, and they're using this to, and they've had such, it's a huge success. I use Visual Studio Code all the time. It is the one of the best, if not the best, JavaScript debugging tools and editors out there. I've just been continued to be impressed with this tool. It is a new Microsoft. If you do anything with APIs, you may be interested in Postman. It is a fantastic API interaction tool where you can create requests and send those off to an API endpoint, see the results that come back. You can save those requests and replay them later. If you build APIs or interact with APIs in any way, this is a great tool to use. And then most recently, GitHub desktop app. They have switched to using Electron for their desktop tools, and it works really well. And then one of the most interesting Electron applications I've run across is this social robot called Jibo or Jibu. I forget how it's pronounced, but it's designed to be not only like an Alexa or a Google Home or something like that, but it's interactive. It's animated. It spins around and it's able to provide emotion. It's like a little animated character sitting on your desk, and it's quite cool to interact with. So the screen itself is an Electron application, and it can change and create expressions as well as show information. And then the software that you use to create your own extensions or interactions or anything with this little robot is an Electron application. So now that we've talked about desktop apps and examples of Electron, I want to show you a little bit about how you get started building with Electron. So the first step, really, before this, is you need to have Node.js installed. And it doesn't matter which version of Node, any modern, stable, recent stable version of Node will work. But once you have Node installed, you have this command line utility, npm, that you can use to install packages. So you want to create a folder for your project and run npm install Electron. That's going to pull down the binaries and other things that you need. And you'll need a couple of files, a JavaScript file and an HTML file. It doesn't matter what they're named. It's just typically they're like main.js or index.js or server.js, whatever you want to call it. And then like an index.html, whatever you want your main screen to be. Give you some vocabulary of Electron. An Electron application starts its life cycle as a Node.js process. So when you open an Electron application, it first fires up Node under the covers, and Node does some bootstrapping, and then it launches from this main process one or even more what's called renderers. And renderers are the Chrome side of things. And it's not the entire Chrome browser. It's just Chromium, the UI rendering of HTML. So there's this under the covers Node uses Chrome V8 JavaScript engine, and so does Chromium. So they're married together. In your main.js file that does like the bootstrapping that I mentioned, this is typically what you'll find as standard kind of code. Require is similar to an imports or a using statement. That's how you bring in external modules or local modules into your Node.js application. So we're going to require in Electron, and off of that Electron object, we're going to grab the app and browser window. And then the app object has a number of lifecycle events that happen. So similar to jQuery has a document ready event, you have this app on ready event that means Electron and Node have finished starting up, and the environment is now ready. Now you can go and do what you need to do. So in this ready event, we're going to create a new main window, a new browser window, and we can set things like width and height. And there's also a whole lot more you can do. You can set positions, you can set minimum and maximum widths and heights. You can make it movable or resizable or not. You can set that kiosk mode so that it's full screen and someone can only interact with that one application. And there's lots of other options too. And then lastly, we want to load in our HTML file to render in that main browser window. And the question I get a lot is, well, this says load URL. Can I load any URL? And the answer is yes, you can point this to some external URL, but there's a couple of issues with that. And I wouldn't, you can do that as a proof of concept, but that's something that you would not want to do long term. And I'll go into that a little bit more later. In your HTML file, just a hello world, you can have something, very simple with a title and a body. And then from the command line, you can use Electron space whatever the JavaScript file is that you created. And when you do that, it launches a browser window and creates, renders what you have in your HTML. And it's interesting to note that the title of the HTML page becomes the title of the window, and whatever is in the body becomes what is rendered in the window itself. But here is the really cool and awesome thing about Electron. Because Electron shares the V8 JavaScript engine with, from Node with the browser, with the renderers, you have access to far more features and capabilities than just your normal browser experience. So anything you can do with NPM or with Node, you can do directly from your HTML. You don't, like I made the incorrect assumption when I first started building Electron applications is that, well, how do I, there's got to be a web server here somewhere. I've got to create my own API and communicate from HTML back to my faux server to get something done. And that's not the case at all. Anything that you can do in Node, you can do directly from within your HTML. So in this example, I'm requiring inside my HTML, the file system module, which is part of Node. That's how you can read and write files and do I/O. And I'm using that to read the home directory of the person that's using the application. Electron extends has its own set of modules and APIs that give you easy access to things like this environment variable home is correctly points to the home directory of whatever operating system they're on. So if they're running this on Windows, it's going to be under, the documents and, folder path. And if you're running on Mac, it's going to be under the user's home, path folder. And I'm going to iterate through all those things and get a list. The other thing I wanted to point out in this example is that, again, this is modern ES6 syntax. You can use fat arrow syntax. You can use promises. You can now use async and await. You can use all those things that are in the latest versions of Node and V8. So with the Electron version 2.0 that was just released, it's running under the covers Node 8.9 and Chromium 61. So you have, as I mentioned before, this is what you're targeting. Doesn't matter what's already installed on the person's computer who's using the application. This is what you can take advantage of. Another quick tip I want to give you is that since it is Chromium, there's some things that you can do, like open the dev tools. So when you as you're building your application, maybe you want to interact with it and use the Chrome dev tools that you're probably already familiar with. So you can add them. You can launch your application with the Chrome dev tools attached, part of the same window, or detached in a separate window. And you can do things like, as you might expect, you can set breakpoints on your code and step through and inspect variables, and do all the debugging things that you would normally do using the Chrome dev tools. Now, you may have heard this before, but there are two hard problems in software development: cache invalidation, naming things, and off-by-one errors. Well, I submit to you that there are actually 4 hard problems. And I don't know what your experience is with, like, in your development environment, but in the teams that I've worked on, it's really, really important to have the right animated GIFs at your fingertips when you're doing code reviews, or if you're interacting with your coworkers on Slack. You got to be able to express yourself correctly. So I created an Electron application called Reactor because in the past, Giphy was just so bad. If you tried to use Giphy in Slack, it was like the worst, right? It was like so bad, it was almost awesome, but not awesome. So this Reactor application I created solves this problem for me. So I can search, for a particular image, and as I mouse over any of those animated GIFs, it'll give me, a preview of what it looks like. And I think, well, that one's okay, but I don't think it really expresses how I feel about my coworker's code that I'm looking at. So I search for Spock Nope, and Spock comes over. And yes, that's what I want. So I click the button to copy it to my clipboard, paste it into Slack or wherever I want it, and away we go. And this is probably the best application I've created in my career. So, to further kind of go along with the Electron architecture and the things that are available to you, remember we talked about there being a process, and which is your Node.js application, part of your application. There's renderers. You can have more or one or more, and then there's some APIs that are common to both. So in the process, what's available to you is app. App was, like we showed, has life cycle events. You can also parse command line arguments. So if you want to set your Electron application to be the default application for a particular extension, you can do that, and you can parse whatever is passed along the command line to open those files. Use app to figure out what are the system and user paths. IPC is interprocess communications. This is how you communicate between the renderer and the main process, is through messages. So there's an IPC for the process. There's an IPC module for the renderer, and you can use those kind of like a publish and subscribe mechanism, where you can say, this is the name of the channel I want to publish this on, and here's the message. You've got native dialogues, so like the file open, save, and info and error messages and those things that I mentioned before. You've got a common menu API. So as you describe what your menus items are and what is going to show up across the top of your application, you've got this one interface where you can build up your menus programmatically, and it'll render correctly on whichever operating system it's running on. You've also got a power monitor module where you can detect not only, is the desktop that I'm running on, is it connected to power, or is it running on battery? But you also get events like it's going into hibernate, or the lid has been closed and I'm shutting down, or whatever. You can just respond to those events and like close connections to other to files or to external sources, so that you can cleanly respond to those kinds of events. There's the tray notification, and then on the renderer side of things, you've got IPC again. There's this special version of IPC called remote, which is almost like a shortcut to sending a command and having the main process do some work for you. There's a special HTML tag called web frame. Now, this goes back to the question earlier about can I load external content into my Electron application? And you can load an external app, but WebFrame, the problem is security. If you just arbitrarily load in content from an external source, you could be opening up a desktop application to security issues. And an Electron application is not sandboxed. Anything you can do, whatever the user has the ability to do, like read and write files or change the registry or whatever their privileges are, your Electron application can do that. So to prevent external content from being malicious and doing damage, you can bring that content in a web frame, and that web frame is sandboxed and does not have access to any of the Node.js and NPM modules and all those kinds of things that could do damage. Modules that are available to both. You've got a clipboard, which I was using in my demo to copy a URL for the animated GIF to the clipboard. You can do text and multimedia type things. There's a built-in crash reporter. So when your application crashes, you can give it an endpoint for you to post some data about that crash back to one of your own servers. There's a native image module, so you can deal with monitor resolutions, DPIs, so you can have alternatives to normal DPI images that you want to use in your application. This is typical for like tray icons, desktop icons, or other types of images. There's a screen module that allows you to not only enumerate the displays that are connected to a desktop, but also has events like when a laptop or a screen is connected, you can know the resolutions of those screens. You can launch your application, and take advantage of multiple screens, so forth. And then there's the all-important shell, which you can use to launch other external applications or to launch, code that you might compile and ship with your application, or to, beep someone's computer speaker, the all-important PC speaker beep. The deploying Electron, there's like some stages of complexity and how you might approach this. So at the very first phase, like if you're doing a proof of concept, or if you're creating something that just a handful of people are going to use, you can take the binaries for the Electron application that are made available for every operating system. So you can take the 32-bit or 64-bit binaries of Windows, for Mac, and for Linux, and then you can take your JavaScript and HTML files and CSS that you've created and just bundle those together in the same folder and hand that to someone, and they can run the Electron executable and run your application. It's really easy. The next step is to take all the code that you created and compile this to an application. On Windows, this looks like an executable with a bunch of DLLs and some other things. So it's typical what you would find when you're building an application. On the Mac, it creates an app file. So it looks, to the user, it looks like a single application. It looks like a single file that they can double click on and run. You can take that a step further and build an installer for your application. And there's installers that you can have for each operating system. And then there's the mechanisms for adding automatic updates. So you can set up a service that your application can point to that will, when the application is running, it'll periodically, hit an endpoint on that server, see if there's an update available, bring it down and notify internally that an update's available. And then you can do whatever you want. You can prompt the user to restart to apply that update, or you can just apply it the next time the application is run, however you want to do it. So recommended tools in the toolbox. There's Electron Debug, which allows, I don't know if this is even necessary anymore, but used to, when you build an Electron application, if you wanted to give someone the ability to hit F12 or whatever the Command-Shift-I, whatever the keyboard shortcuts are for bringing up the dev tools in your application, if you use Electron Debug, you give your users the ability to do that. I think that's built in now. But Electron Debug gives you some other things around, it makes it a little bit easier as you're building your application. Electron Reload is another developer nice tool to have, kind of like hot reloading when you're building a web application. Typically before Electron Reload came along, you build your Electron application, you launch it, you notice something it needs to be fixed. Now you got to close it and restart it again, make that change. Well, Electron Reload, it will detect any HTML, JavaScript, or CSS changes and will automatically essentially refresh or restart your web interface so that you can immediately see those changes and keep on iterating on your application without having to restart it. Electron Packager is got a number of great tools to create the executables from your application. Builder is what takes that another step further and creates the installers for your application. Electron Updater, there's update capabilities built into Electron, but Electron Updater makes it just even more easy to create those install and update events. And then if you prefer, like I've in the past, I've used Mocha quite a bit for doing testing and unit tests and behavior tests in my application. Electron Mocha, or Mocha by itself, is not aware of all the APIs that are available to Electron. So Electron Mocha is like a drop-in replacement of Mocha that does understand the APIs that are available so that you can use those under your tests. There's some other tools that GitHub has created. Devtron is a Chrome extension that you can add to your project, and it'll do things like give you insight into the IPC messages that are going back and forth between your renderers and the main process. It's got some linting capabilities. It'll tell you if you've done something, prescriptively wrong or haven't included something in your application that they recommend that you do. There's also Spectron, which is a whole UI testing framework. It's built on Chrome driver and WebDriver that you can build UI tests for your Electron applications. And then getting started with Electron, there are a number of really good boilerplate projects out there. My recommendation, though, I'll give these to you. There's Electron boilerplate, which is kind of front-end agnostic. It's just plain HTML, but it gives you a lot of tools that help you to build, create executables and create installers for your application. And then there's a React boilerplate. I'm sure there's Angular and Vue by now if if those are your front-end tools of choice. But I will say that I've done a number of workshops with Electron and helped a lot of folks get in it. And what helped me the most when I got started with Electron is to build an Electron application from scratch without using a boilerplate. Once I understood all the work that goes into building like this infrastructure beyond just a hello world application, then I knew what the boilerplates were doing for me, and I better understood the benefits of using a boilerplate. Whereas before, when I tried to start with a boilerplate, I didn't know what part I was having issues with. Was it Electron or was it the boilerplate application, code that was trying to be helpful? Another great place to start, or another option that you may want to consider, is this project called Electron Pre-Built Compile. It is a drop-in replacement for the Electron executable. It was built by one of the original core members of the Electron team, and this executable has built into it Babel, TypeScript, and GraphQL. It understands a lot of things natively, things like React, Less, Jade, view components, these things that would normally require you to set up some kind of transpilation in your Electron application. This knows all these kinds of things right out of the box. So you don't have to have that build step to do the transpilation. You can just ship your application with TypeScript or with GraphQL capabilities or with React, and it will handle those types of components and features on the fly. Building an Electron application, you can use whatever front-end technologies you're most comfortable with. If you want to use just plain HTML, JavaScript, and maybe some jQuery, there's no shame in doing that. This is an application that I created. It took me about 2 weeks to do it, and most of that was all the back-end stuff for the reports. This is just HTML, JavaScript, some little bit of jQuery, and I think I use Bootstrap as my CSS styles. And it looks kind of like a web application, but it gets the job done. It looks pretty nice. I was pretty happy with it. Customer was pretty happy with it. There's a CSS framework called a Photon Kit that makes your applications look even less web-like and more native. Currently, it's just for Mac UI. I think the long-term goal is to add a bunch of UI elements to make it look like a Windows app when it's running on Windows and make it look like a Linux app when it's running on Linux. So right now, if you use Photon and you run your application on Windows, it just looks like a really beautiful Mac app running on Windows. I don't have a problem with that. So this is an application that I created using that Photon kit that made it look more, Mac native. And I was really pleased with the results and how it behaved, how it looked, all the windows, all the elements and styling, the icons that it provides. It was pretty nice. So some tips on building Electron applications. When you're using a browser and you mouse over a link or something you can click on, especially if you're on a Mac, you get this little cartoon hand character, that points at the thing that you can click on. Well, that's fine for web apps, but that's typically not what people expect to how their desktop apps behave. So, it's a little thing, but set the CSS so that it's always using the default cursor for everything, every kind of element. If you have multiple windows in your application and someone goes to close a window, if there's a chance that they may want to see that window again, well, don't close it, just hide it. And then next time they go to see that window, you can instantly, display that instead of the few milliseconds it could take to recreate that window and then re-render it and bring it up on the screen. If you have background work that you're doing, such as going and fetching, stuff from APIs, building files, interacting with files, fetching stuff from a database, any of those kinds of things, this is kind of like the poor man's multitasking or multi-threading. Is you want to do that work on a main thread, or you could do that work on an invisible window. Some folks have gone that route. So you can use IPC to send a message to the main thread to say, look, go do this thing, like open up a file dialog and allow someone to save a file. And you send that message to the main process. The main process does whatever it needs to do and sends a message back to your renderer to say, I'm done, or this was the result, or whatever, that you can then display to the user. And this allows your application to continue to be responsive and, nice to use while that work is being done behind the scenes. Local storage is typical to any desktop application. Is you need to be able to, keep track of state, keep track of files, do things and remember things as your application is closed and reopened. Typically, when on desktop applications, you want to, You want the size of your window to be the way you want it to be. You want it to, you know, be positioned on the right spot on the desktop. And when you close it and reopen it, you expect your application to be in that same spot again and to be the same size again. And you can do that just by capturing an event in the main process, reading those XY coordinates and the size of the window and storing that locally, and then just reading that back up, the next time the application launches. So things like that, plus, any kinds of files that you work with locally. The first approach is just read and write JSON files. You got JSON data that you're creating inside your application from JavaScript. You can just read and write those to the applications directory, and use something like FS Jetpack, or there's another one called FS Extra that's promisified, and it's like the FS module the file system module that comes with Node, but with a lot more things attached to it that make it easier to read and write JSON files. To take that a step further, if you need like a database type storage in your application, NEDB is a great start. Under the covers, it's just reading and writing JSON files, but the API is kind of like a subset of MongoDB, so you can query it. You can, store records, records at a time. And then another step even further than that is an application called PouchDB that is the entire CouchDB API replicated in JavaScript, so that you can not only interact with it just as you would with Couch, like you would with CouchDB. It has synchronization capability. So if you want one of those offline type scenarios where you want to use your application in the field, and then when they come back to the office or have cell phone access again, they can synchronize. The PouchDB app can synchronize with a CouchDB server. If you're running internally and in your organization and want to use things like relational databases, absolutely. Anything you can do with NPM, any kind of module that's available on NPM, you can use in your Electron application. So Seriate, if you use SQL Server, Postgres, MySQL, Oracle DB, messaging systems, RabbitMQ, ZeroMQ. Literally, there's hundreds of thousands of modules that are available on NPM. You can use those in your Electron application to do just about anything you want. From here, this is the one-stop shop for everything Electron. If you essentially go to Google and search for awesome Electron, you're going to land on this repo, and it's the exhaustive list of all articles, videos, tutorials, sample applications, other open source projects, tons and tons of things to point you to building and helping you build your Electron application. If you have access to Pluralsight, Jake Trent, Electron Fundamentals is fantastic. It's the course I wish I had created if I were a Pluralsight author, and highly recommend that. There's also a Pluralsight course that Rob Connery created on Electron called the Electron Playbook. That's also really good. It's kind of it's not like an introduction to Electron. It's more like, here are the things I've learned to do with Electron, and it's kind of like tips and tricks from the master. And then the documentation at electron.atom.io is really, really good. There's some tutorials and how-tos, and that'll step you through getting your first application up and running. I don't have this on the list, but in my GitHub repo, I have an Electron workshop that I've done several times. All the exercises and the instructions for doing that workshop are in an Electron workshop repo if you just search if you go to GitHub/Reverent Geek, you can find that. That may be a good way to get started. And then the Slack community for Electron is really active, super helpful. If you have any questions, you run into any kind of issues, you can post them there, and expect to get some friendly responses. Last thing I want to leave you with is you don't need permission to be awesome. This is I really, really believe that those of us in technology have a unique opportunity to impact our community and our world in just very powerful and significant ways. The technologies that you're learning about here at this conference, the things that you geek out about, I want you to keep in perspective that you have the ability to make a huge impact on the people that you work with, the people all around the world. Technology is awesome. And I encourage you to take the things that you're learning and that you go and be awesome. Thank you. Again, shameless plug. If you enjoyed some of my silly artwork, I have a leadership talk at 3 o'clock that's mostly all humor, that's mostly all silly stuff, and it's all hand-drawn. So I would love for you to come to that talk in this room at 3 o'clock. Is there, got a few more minutes. Are there any questions I can answer? Yes. So are there concerns about security? There are security concerns. I think the question that you're asking is there a concern about having Node, running on the desktop and what Node is capable of doing? So that concern is really the concern of any desktop application. Any desktop application, it's whatever the security context is of the user that's running that application can do anything that user can do. So if that user has access to do damage to the registry or to access files on a network, sure, you got to limit your risk there. The security question that I typically get is, I want to protect the the intellectual property of my application. How do I do that? If I ship an application, and it's HTML and JavaScript, people are going to know what's going on, and they can, so the way I've seen companies address that is building some kind of, so there's ways that you can extend Node that aren't just JavaScript. You can write C. If you got C libraries, you can, take your intellectual property and create a C library of those things and use that from in your application. I know there was one company who used Haskell. They took all their intellectual property, and because they were just super into using Haskell, and Haskell is cross-platform, they just compiled all their intellectual property code into Haskell DLLs and then invoked those from within their application. Right. I mean, you can create basically a bundled file. It's essentially a zip file. It doesn't have a zip file extension, but if you compress your application and go that route, it's all in there as a resource file. But somebody who knows what they're doing, they can just open that up and parse it. Any other questions? Yes. Performance issues with V8? Yeah. So a common concern for Electron applications is performance with V8 and Chrome using memory and using a lot of resources on the computer. Yeah, there's a meme going around with hey, what would you do with an 18-core Mac? Run two Electron apps at the same time, man. It is true. There are things. I think mistakes were made and things got hurt. With Electron, especially like the Slack app that gets a bad rap for being a resource hog. But some of that has to do with how many Slack communities you're connected to and how much stuff it's having to do in the background to keep all those communities up to date and so forth. I don't have a real good answer. I mean, there's the base application that if you run a hello world, it's not that large. It's like 400K, plus some resources. And depending on how many browser windows you create, it's going to, each one of those windows is going to eat into another chunk of memory. But in my experience, the applications I've created have been fairly simple and have not had any performance issues or caused anyone, to scream at me, so I think it's a success. Yes. Okay. So the recommended development environment for Electron is that I would recommend is Visual Studio Code. Visual Studio Code is not only a great JavaScript debugger, but it has some knowledge of Electron applications built into it. So, like when you go to debug an application, you have a number of choices of, is this a web app? Is this a Node.js application? Excuse me. Is this an Electron application? You can choose Electron, and it knows how to attach to the Electron process. It knows how to, give you the capabilities of stepping through your code and so forth. So the combination really is Visual Studio Code for debugging the process side of things, the main process, and then you can use the Chrome dev tools that are built into V8 and Chrome to debug and step through your front end, so to speak, code. That's the two-headed thing for development. Does that answer your question? I'm sure you could use other tools, like some folks are really keen on using WebStorm or something like that. Sure, you can use Node to attach. You can attach to that process, or even Visual Studio. Visual Studio Code is what I would recommend. Yep. All right. Thank you. You've been awesome. Go and be awesome.